Welcome to another lesson with me. Today we're talking about calculating correlation coefficient. The question here is, how do we quantify how closely two variables are related together? For example, in this particular, how much is the gradient of the beach is related to the median diameters of granules of sand on this particular beach. It's a set of data that comes from this particular source. There are 9 observations in total here, so n in this case is equal to 9. And I also calculated the sum of the x's and the sum of the y. The sum of the x's is written as sigma x. The sum of the y is written as sigma y. X and y in this set of data are continuous data. The first thing that we should do to check whether this set of data this x and y are related is to plot a scatter plot as shown here. From this scatter plot, it is easy to see as x increases, y also increases. So we can suspect that there is a linear correlation between x and y. The formula for calculation correlation is given by this. That is the covariance of x and y divided by the standard deviation of x and standard deviation of y. The formula for covariance is this one. And this funny symbol here is called sigma. It just means the summation. So sigma x for this set of data is just basically x1 plus x2 plus x3. Sigma y is y1 plus y2 plus y3. And sigma xy is the product of x1 y1 plus x2 y2 and x3 y3 for this set of data. When you replace xy by xx, then this particular formula gives us the variance of x. So sigma xx just basically means the summation of x squared. And n here represents the total number of observations. So previously I have 3 sets of observations, n equal to 3. The square root of the variance of x is the standard deviation of x. So here is the formula for standard deviation of x, and usually this is written as this. Note for sum of x, this is for this set of data, sum of x is x1 plus x2 plus x3. So for this, we have to sum up all the x's first and then square. Sum of x squared on the other hand means square all the observation individually like this, x1 squared plus x2 squared plus x3 squared. So make sure we distinguish sum of x, everything squared over here, from sum of x squared. In terms of manual calculation, this is the preferred formula. This particular standard deviation also written as this. The formula in yellow basically means is the square root of the sum of all the square of the differences between the observation and its mean divided by the number of total observations. The formula in yellow is easier to write and easier to understand, but for in terms of manual calculation, the one in black is preferred. Standard deviation of y is calculated using the same method as standard deviation of x. And the only thing that we do is to replace the x with y. Similar to standard deviation of x, standard deviation of y can also be written as such. That is the square root of the sum of the square of the differences between y and y bar, that is the y mean, over the total observation. It is often easy to organize the data into a table as this. And here's the column of x squared. And basically the first cell here is basically 0.17 times 0.17 to get 0.0289. The next is 0.19 everything square. And the third one is 0.22 everything. As a review of the notation, sum of x is denoted by this, and this is 2.97 from here. and sum of y is this symbol, and here is 28.68 from here, and sum of x squared in this case is roughly 1.33525 as indicated in this table. Here I expanded the table into two more columns of y squared and x and y. So for example, this particular number here is basically 0.63 square. And the next one is 0.7 square. And following here is 0.82 square. And next one is 0.88 square, and so on. Here, this number here is 0.17 times 0.63 to get that number. The next one is 0.19 times 0.7. And the next one is 0.22 times 0.82. And we create all the numbers and we sum all of them up at the bottom. In terms of notation, this value here is the sum of x squared. Here is sum of y squared, and this one is sum of xy, that is the product of x and y. So now what we do is to put all the numbers together in order to calculate the covariance of x and y. So first we need the sum of x and y. So sum of x and y is here. So 15.55855 minus sum of x, which is 2.97 over here. And then sum of y is next door, which is 28.68. And then all of this is divided by 9, the total observation. And the numerator now is divided by 9 again. And here's the result of the calculation. So now we calculate the standard deviation of x, which is the square root of, and then I need to pick up the sum of x squared, which is here, which is 1.33525 minus then the sum of x, which is here, 2.97, everything square divided by 9, and the numerator again is divided by 9. And here is the solution. So now we calculate the standard deviation of y. So we first start by square root. I need the sum of y squared, which is here, 206.2462 minus sum of y, which is 28.68 square divided by 9, and the whole numerator now is divided by 9 again. And if we do the calculation correctly, here's the answer. Now we do the calculation with this formula. The covariance is 0.677128 divided by standard deviation of x is about 3.572310 multiplied by the standard deviation of y, set 3.57231. And if you do this properly, this is roughly equal to 0.954194 ... And what this value suggests to us is that there is a strong linear correlation between x and y, and the number here is almost equal to 1, 0.954. This value is consistent with the scatter plot that we obtained. The physical interpretation of this is that as the gradient of the beach becomes steeper, the wave that can reach the sand become less and they become weaker. So the sand get less erosion. There's a direct relationship between the gradient of the beach and the median diameter of the granules. As the gradient of the beach becomes steeper, the median diameter of the granule becomes larger because the strength of wave is weaker, therefore the sand has less erosion and is able to maintain its size to become larger. As a practice, you may want to redo the calculation for the correlation for the previous set of data about the gradient of the beach and the median size of the granule of the sand. And here is another extra exercise for you. This is a set of data, and calculate the correlation coefficient and check your answer here. Thank you for watching.